Hi guys, and welcome back to the ACE Academy. In this video, we'll be looking at series circuits. As you guys can see on your screen right now, I have sketched a series circuit consisting of two resistors in series to a cell. We can see that we have voltmeters across each component, and we have ammeters measuring the current flowing through R1, the current flowing through R2, and the total current in the system. Okay, what we are going to do first is we are going to go over some theory, and this theory is extremely important. It will allow you to understand and apply your knowledge to series circuits much more clearly and much more effectively. The first bit of information that we need to know when tackling a series circuit is that the current is the same at any point in the circuit. This is extremely important. This means that the total current in the circuit is the same amount of current that is passing through each component. So I could quite simply say that A3 is equal to A1, which is equal to A2. And all of these ammeters will read the exact same amount of current, which is 3 amperes. The current in a series circuit does not change. I will have 3 amperes flowing through the circuit. It will go along the wires. It will pass through resistor R1. It will pass through the ammeter A1. It will then go ahead and pass through the resistor R2. It will pass through ammeter A2, and it will come right down the wire, pass through ammeter A3, and come back to the battery. That's how the current will flow in this circuit. The second important bit of theory that we need to know when tackling a series circuit is that this circuit is a voltage divider. Now, I know that a lot of you guys won't understand what I mean when I say voltage divider just yet, so I'm going to elaborate. When I speak about the circuit being a voltage divider, it means that the sum of the voltages across each component will equal to the source voltage. We know that the battery is supplying a voltage to the circuit, and in this case that voltage is 12 volts. The voltage across each component when added will give us this 12 volts. This means that VR1 plus VR2 will equal to the total voltage in the circuit. Let's go ahead and test that out. VR1 reads 9 volts, and 9 volts is the voltage across R1. VR2 reads 3 volts, and that is the voltage across R2. When I add 9 plus 3, I get 12 volts, which is equal to my source voltage. That is very important. That means if I have my source voltage and the voltage across one of the resistors, I can just take my source voltage minus the voltage across that resistor to calculate the voltage of the remaining resistor. It's a very important skill that you guys need to learn. We are going to go ahead and do an example together just to reinforce this bit of theory. On your screens right now, you can see that I have a completely new circuit that I have sketched. This circuit consists of two resistors, R1 and R2, and a battery. Let's look at the quantities that we know in the circuit. We can see that we have been given the resistance values of R1 and R2. R1 has a resistance of 4 ohms and R2 has a resistance of 2 ohms. The next bit of information that has been given to us is the voltage across R1, and that is 8 volts. We have not been given any other information with regards to the circuit. We are now going to go ahead and solve this circuit, which means we are going to find the voltages and the currents going through each component in the circuit, as well as total voltage, total current, and total resistance. As you can see, we have a number of questions to complete, and these questions will serve as a guideline in order for us to solve the circuit effectively. The first question states that we need to calculate the total current in the circuit. Now, in order to calculate current, we are going to need resistance and we are going to need voltage. And this comes from the equation I is equal to V over R. We can see that the only component that we have a voltage for and a resistance for is R1. But if I were to calculate the current going through R1, would that be the same as me calculating the total current in the circuit? Yes, because if we go back to our series circuit theory, we know that the current in a series circuit is constant at any point in the circuit. The current through R1 will be the same as the current through R2, which will be the same as the total current in the circuit. So I can simply use the formula I is equal to V over R, substitute in my values, which would be 8 over 4, and I would obtain a current value of 2 ampere. I now know the current at any point in the circuit. Really important. Now that I have the total current in the circuit, it allows me to work with the circuit more effectively. I have more information for the circuit. Our next question tells us to calculate the total resistance in the circuit. We can do this by simply adding up the values of each resistor in the circuit because all the resistors are in series. So we can say RT, R total, is equal to R1 plus R2, which is equal to 4 plus 2, which is equal to 6 ohms. Now that we have the total current and total resistance in circuit, it would be quite simple for us to calculate the total voltage. All we have to do is use the formula V is equal to IR. Substituting in total current, I would get 2 amperes. Multiplying that by total resistance, which is 6 ohms, I have now obtained the total voltage in the circuit, which is 12 volts. I can go ahead and list this as well. Our next question asks us to calculate the voltage across R2. This can be done in two ways. We know the current passing through R2 and we know its resistance. So we could simply say V is equal to IR, which is equal to 2 times 2, which is equal to 4 volts. Or we could use the voltage divider rule, which tells us that the sum of the voltages across the components in a circuit is equal to the supply voltage. So we know that the supply voltage is 12 volts. We can subtract the voltage of the known resistor, which is 8 volts, and we would obtain 4 volts. These are two different methods in order for us to calculate the voltage across R2. In our final question for the circuit, it asks us to calculate the energy transferred to R2 in 2 minutes. Now, a lot of you guys might be confused as to how we're going to do this, but I want you guys to think back to the first video in the series, where I was giving you a list of components and a couple known quantities and the equations to define these quantities. When we speak about energy, one formula stands out, and that is the formula for voltage. V is equal to W over Q, where W is the work done and Q is the charge, because voltage is the work done per unit charge in the circuit, and work done is actually energy. Okay, so if we wanted to calculate the work done to R2 in 2 minutes, we can simply substitute in the voltage of R2, which is 4 volts, and we would obtain 4 is equal to W over Q. There is still one more unknown that we haven't found in order to make this equation work, and that is the value for Q. We need to know how many charges flow through R2 in 2 minutes. In order for us to calculate that, we can use the equation for current. Current is equal to Q over T, which is charge over time, because current is the rate of flow of charge. So I can simply substitute in the total current for this circuit. I would obtain 2 is equal to Q, and how over what period of time? It would be 2 minutes, which is 120 seconds. Therefore, the charge passing through R2 in 120 seconds is actually 240 coulombs. I can now go ahead and substitute in this Q value into my equation in order to calculate W. I would get 4 is equal to W over 240. And manipulating this equation, I multiply both sides by 240. I would obtain W is equal to 960 joules of energy. So this means that 960 joules of energy is transferred to resistor R2 in 2 minutes. It's quite simple, guys. All you would need is a bit of practice in order to master this part of electric circuits, but of course with more practice it would become easier. That's it for me, guys. All the best, and I will see you in the next one.